for I guess I'm going to assume that the sound is okay, unless I hear otherwise. So, okay. Thanks everybody for joining me today. I'm really excited to share this material with you. And I hope that you've all been enjoying. Oh, thanks, Kote. Okay, now that I'm unmuted. Welcome everybody. Thanks for joining me for this talk. And I'm really excited to be here. I'm going to go ahead and share my screen. Share the entire screen. I hope you've all been enjoying the conference so far. Okay, great, thanks. And can you see my screen? So you probably can see this right now. Okay. I am working on one monitor today instead of two, so just bear with me as I make sure that you're seeing the right thing at the expense of my seeing something. So let's go ahead and present. Okay, so so the talk is titled "Make the Right Thing the Obvious Thing: The Journey to Internal Developer Platforms." And I know that Kote has just been talking to you about platforms, so you'll have some context. So this should add to your general understanding of platforms, internal developer platforms, and how VMware sees it ultimately. So what I want to cover is basically sort of broad strokes. Where are we today? How have we gotten here sort of historically to how we conceptualize internal developer platforms today, how you can think about them, what kind of things you might be looking for when you evaluate internal developer platforms. And then I want to give an example. So I'm going to do a demo and I'm going to use VMware's technology to do that, just as an example of our take, our opinions in terms of what an internal developer platform can look like, so that you have that as an example. Having said that, VMware's technology is built on top of a lot of open source technology. So it's also a way to understand how you can take advantage of the open source of the CNCF pool of products and build something. So the question is really, what is an internal developer platform? So starting from that, I want to take a walk through history a little bit, because the phrase, the word, the internal developer platforms might be relatively new. Some folks haven't heard it yet. It's been sort of gaining popularity over the last few years, but conceptually it's not new, right? It's something that I think we think about, and we had just introduced this idea of Backstage as a new technology that provides a framework for building a UI on top of a platform. So putting Backstage together with Kubernetes, we can achieve sort of a new goals in terms of internal developer platforms. That's where we are today in terms of technology. So I was going to go into VMware's, an example using VMware. VMware's Tanzu Application Platform is our internal developer platform, complete with a full Kubernetes stack. It can run on any compliant Kubernetes, but it really takes root in this idea that Tanzu, VMware kind of has experience up and down the stack. So we put this together as a platform. And it addresses both developer needs directly by bringing some of the functionality, even outside of Backstage, into the IDE. I'm going to show you a demo of how a developer can work within their IDE and into Kubernetes, and then we'll switch into also the developer experience with the Backstage-based developer interface. But you'll be able to see through that how much is automated and addresses sort of this outer loop that is the concern of the platform team, DevSecOps. And it's all built on top of a large array, more than what's shown in this slide, of open source software. So I want to show you, I'm going to do a live demo for you, but before we get there, I'm just going to show you a few screenshots so that you can have sort of like an overall understanding of what's included in this platform, in this internal developer platform, and have some placeholders in your head as we go through a live demo. And I don't know if I can do a time check at this point, since I don't know what the schedule is. I don't know if Whitney or Quincy, if you guys can pop in and tell me how much time I have, that would be helpful. So having said that, okay, so here's one screen. So one of the things that we mentioned was this ability to bootstrap applications. We're using the platform as a way to provide a golden path for bootstrapping applications. And so one of the things that's included is a set of templates for starting all kinds of applications. There are some that are included by default, but of course, if your organization has preferred architectural patterns or technologies that can serve as starting points for new applications, then a developer would have a place to go to actually start a new application. So they're basically templates for jump-starting application development, and they can include sample code, which is also a way of enabling developers in having a starting place to see how to use certain technology. We can bring that concept directly into the IDE. So this is a screenshot of visual code in particular, not of Backstage UI, but bringing that idea into the IDE, because that's where developers probably want to start new applications and get right into coding, and then iterate directly from the IDE into the application deployed in Kubernetes. So I will show you that inner loop in just a few minutes. And then, of course, once you're ready to actually deploy your apps to production or to a shared dev environment, then you want to onboard your application and have it run through a complete secure software supply chain. So again, there's a golden path is provided so that there is a default path to production, complete with testing, scanning, providing images in a methodical way, adding configuration in a uniform way, but also using sort of conventions based on if your application is Spring or .NET or Python or Ruby or whatever, right? They might require different configurations. So kind of using conventions within this golden path to get your app to production. So that would be baked in, but you get to follow it and inspect it as a developer. You get access to see what's happening. And then once your application is running, rather than going directly into Kubernetes, or having to extract your logs yourself, having all of that information brought to you. So you see the Kubernetes resources that are represented. You can see your logs, change log levels, etc. You could even see the different metrics that are coming out of your application, whether it's generic ones like memory or HTTP requests, things like that. Or as you can see, the last one in the list here is actuator. So that would be a particular tie-in to Spring Boot applications. And then, of course, applications might expose APIs. And so those can get registered so that other teams can find the APIs, test them, and use them. And it's also a way, so for not only to share your APIs, but discover APIs across the organization, hopefully reduce tech debt, increase collaboration. And also a way to sort of just inspect what are all the other, besides what you as a developer own, your set of applications, or what your team owns, what do other teams across the organization own? And what are the, maybe what's the architectural, dependencies of those applications? How do you understand those applications? Can you view the documentation? Can you find the source code? Can you find the team that owns them with the contacts for the different developers on the team? All that information is included in this sort of idea of a system catalog. So suddenly, again, you can see how you can start to better understand all of the applications at the organization, organize information, collaborate with other developers, and more easily onboard and organize and share information about your own applications. And then finally, since all applications are going through this path to production and they all get scanned, the platform can also surface a lot of information to give you a good picture of like what all the vulnerabilities are that are found across applications, which applications contain them. So it also gives you, of course, if an application has vulnerabilities that are critical or high, or that you've decided that the platform team has decided are not acceptable, they would not be deployed to production. But you can still get a consolidated cross-application view of your general security posture. So with that said, I want to do a demo, and I want to keep 3 use cases in mind for this demonstration. So one is, as a developer, I want to be able to quickly build and deploy applications so that I can focus on developing new features. So for that, I'm going to show you that experience that is contained within the IDE, where as a developer, I spend most of my time, and I just want to build and deploy quickly. The second one is this idea that as a developer, I want to be able to deploy my applications in a scalable and secure way and provide my end users with a safe, reliable, and performant experience. So that has more to do with that path to production and then having the applications managed in runtime. So I'll show you that with a product live. And then the last use case I want to talk about is, as a developer, I want to be able to collaborate more effectively with my colleagues so that we can work together to build high quality applications. So you've seen this already in some of the screenshots, the documentation, the software catalog. I'll just click into some of those and show you a little bit more detail in the UI. So that having been said, we'll start with this first one, the build and deploy quickly. So if I go to Visual Code. So, okay, so as a developer, most of my time will be spent in my IDE, right? So we said that there are these accelerators, these templates, a good starting point for an application. So here's a list of accelerators that are included in the platform by default. So let's say I choose a simple Java web application. I have a few choices here of what I could use. So let's say I choose Java 17, and let's just, or actually this one, let me choose this one. Yeah, okay, so we'll say Java 17, and we'll just say use Spring Boot 3, and we'll say next step and generate a project. So we're going to store it in my workspace. So it basically creates an export. It exports a zip file, and then the IDE asks me if I want to open it in a new window. So I'll just say yes. So here I am. This is my new project, and it's located only on my machine, right? I haven't checked it into any kind of Git repository yet. But as you can see, beyond having some pre-selected dependencies in my POM file, this is a Spring Boot application, I also have some source code. So this is a very simple example of how you can include, for example, a controller with some sample code in case somebody is new to this particular web development. But this can be anything that you want, or it can have conventions or default code that you definitely want to include, or it could have architectural, like if I need to use a database, it could have architectural patterns or database choices or things like that that we want to establish as sort of that golden path for a certain type of application. So having said that, there's a few other pieces in here over and above what you might get in a default Spring Boot application, right? So one of them is this idea of a tilt file. And this is a mechanism by which I can put myself into this quick loop of quick iterations where I make changes in my IDE, but I see those reflected immediately in Kubernetes. So what I'm going to do here is say live update start. And so that's going to start tilt in taking my code and moving it into Kubernetes. But actually, the first thing you see here is an error, right? It doesn't do it. And that's because I have to give explicit permission to get into, and again, it gives me the hint here, allow Kubernetes context on this cluster. So as soon as I paste that in here and hit save, then I've said, yes, I'm sure I want to do this. And basically what I am accepting is that I want the code that is on my local machine, on my disk, to be sent into this cluster. And eventually, as I make code changes, I want my changes to kind of be hot swapped into the cluster as I code so that I can see at my changes quickly tested or reflected in Kubernetes. Now, I wouldn't want to do this, of course, in production, and possibly not in a shared dev environment, right? I want to do this in a Kubernetes cluster that is dedicated for me as a developer for this quick iteration, right? Or maybe for my team. So I have to explicitly say, yes, I'm agreeing to this. So that's what that line is about. Now, in the meantime, you can see in the bottom logs that the application is being processed. So the first time that I start this live update process, it's going to take a little bit longer because the source code on my computer has to be transported into the cluster. So basically, this whole directory of files that you see here on the left in my browser in the Explorer window is moved into the cluster. That's done using, it's actually done using a container registry, as sort of using it as an FTP server. So all of this stuff gets packaged into an OCI image, not one that you would run in Kubernetes because the application hasn't been compiled yet, but just as a way to transport the files into Kubernetes. And then once that happens, inside of Kubernetes, we're using a product called KPack or Build Packs, Tanzu Build Service, but it's based on this open source Build Packs project to actually containerize that application into a container that can run inside a pod. And then it is enriched with all of the configuration, the YAML configuration that you need to deploy it using the runtime provided by Knative, yet another open source project. And so all of this has to happen the first time in the background so that I have the application running the first time. So I think we're getting close. And in the meantime, I'm going to start another window here so that I can just get the Kubernetes service that's going to represent it. So there it is. Okay, so there, the application is running. So I can open it. Let's refresh that. Let's give it another second. Okay, now it's ready, so we'll refresh. Okay, so there's my application is running now in Kubernetes. So that took a few minutes, right? And that's not rapid iteration. What is rapid iteration is now that we're in this position, now as a developer, if I want to make changes, then for example, if I just want to say welcome Spring 1, as soon as I hit save, let me switch windows here. So this is the tilt output. As soon as I hit save up here, you see some action on the bottom because tilt is going to notice that I made a change to a class file. And it's going to hot swap that into the Kubernetes cluster. And immediately I can go to the application running in Kubernetes and see that change. So now I'm in that quick iteration position, right? And so this is leveraging a few different open source projects. I mentioned Tilt. It uses Carvel to actually transport the application, et cetera. So that's the inner loop developer experience. Now, there's another file here that defines, it's an example of how I would onboard this application into once I'm ready to deploy this to a shared dev environment or to production, I have to get this application onboarded onto the secure software supply chain so that it actually gets tested and scanned and deployed to the right cluster, right? This is just not to my iteration cluster, but to the actual proper dev or production cluster. And so I have this partially finished configuration file here that says that the way to onboard this application is to apply this to Kubernetes. It defines my application as a workload, but you can see here that this field is blank, right? And that's because I haven't yet checked my application into a Git repo. So I have another. I have this open. I've done this separately. So here. In a separate one, I've checked that application into GitHub, and I've enriched that workload definition with the proper Git address, and then applied this workload definition to a cluster with Tanzu Application Platform. So I'll just show you how that looks. So I think I have two clusters here. So here's that application now onboarded. Oops, sorry. So here are the workloads that are deployed, and it includes. I'm changing my. I installed a new cluster, so I have to get you the right one. So let's go with this one. There we go. Okay, so this is my Tanzu Java web app. Oops. So these are the workloads, and here's my Tanzu Java web app deployed, and so. Here, by applying that workload to my cluster, I have now onboarded it. And from that moment on, every time I do a change and I commit it to Git, this resource here on the left, the first one, is basically watching that Git repository. So I have to onboard once, and then that application is going to be always updated automatically by the platform, right? This is sort of a pull model where this pulls the Git repo. So at that point, my changes would be downloaded to the cluster. My code would be tested. That image would be built in the same way that I saw it built when I was doing my quick iteration for my IDE. Then it would be scanned. And so it would have to pass all kinds of scanning. And then after that, the next set of activities that happen are configurations. So each one is enriching that YAML that's going to represent how the application should run in Kubernetes. And they're based on different conventions. So if it's a Spring Boot application, which it is in this case, it'll get, for example, the health endpoints will be configured properly, things like that. If I need, and then there's some other functionality here. So, auto publishing APIs or binding my application if I did have it, if I did need to bind it to a database, all of that would happen here. And then finally, that configuration is generated. This can be either to a Git repository for that Git ops model based on Git, or it can be published as files, again, in a container image using an image registry as that handoff between building and deploying applications. And then that information would be pulled and deployed actually to a running application, in which case this application would be running now in production. So there we go. And so beyond that, that is the end-to-end secure software supply chain that you as a developer can follow and see, right? And this is the golden path. Now, other things that you can see are, in general, the entire software catalog for applications in your organization. You could see things like the overview. So if the application, so you can see where the source code lives. If the application had tech documentation, I'll show you. This one doesn't have docs, but I'll show you another example. You can see, most importantly, what's actually running, right? So you can go to your runtime resources and you can say, show me what's actually running, because there's different pods that are involved in getting that application to production, and they're all there for observation, but there's the pod that's actually running. So you can say, okay, let me look at that. You can see the hierarchy of Kubernetes resources from that workload that you created all the way down to the pod that's running. You can see the log files. You can change log levels, for example. All of this is available through this. So the idea, right, is to make this a good experience for developers, right? Bringing everything to the application level. So these are some of the things you can do. We talked about this live view to look at things like memory or other things, to see actuator endpoints. You click on actuator endpoints and you have all of the ones coming from Spring here available. Okay, as I mentioned, I'm reinstalling new platforms, so I might have missed something in the configuration. But and then you can see, of course, environment variables on your pod, etc. So all of this information is available to you as a developer, so you can easily observe and troubleshoot your application. And then we have documentation. So again, I'm going to switch over to another installation where I have documentation. So here, for example, if your application had documentation, you could publish it there. However you want to write it, just get it published. Also APIs, you have their accelerators. APIs can be here. So if you are either publishing or discovering, you have the ability to, full Swagger capabilities of even testing out APIs. Here we go. So that's an API that you could use, for example. We've seen the different workloads, supply chains, and finally that security analysis that gives you a good picture of what is your security posture across all applications. And from here, you can link into applications, you can link into the vulnerability database and get more information about whether fixes are available for those things that you can incorporate. So I think that's really all I want to show you.